Student friends, in yesterday's lecture, we studied the topic number 2, that is modulation. Just we have introduced the definition of modulation, where we studied that modulation is the process by means of which some of the parameters of high frequency carrier wave is varied in accordance with that of the parameters of the signal to be modulated. We studied that. In this definition, two waves are involving. One is a carrier wave and second one is the signal to be modulated. The signal to be modulated is superimposed on the carrier wave and then it is transmitted from transmitter toward the receiver. This process we can call it as it is the modulation. We also studied the need of modulation along with its importance. We studied that modulation is needed because almost all the signals are going to lie within the frequency spectrum. And direct transmission of frequency spectrum through the atmosphere, it is not possible. So that's why modulation is necessary. Due to modulation, distance covered is very large. Time required to cover large distance is less. Speed of the signal which we want to communicate is also more. Due to modulation, height of antenna, receiving antenna is reduced. Due to modulation only, one can design amplifier, one can design receiver, transmitter very easily. One can adjust the bandwidth so as to improve the signal to noise ratio, to reduce the noise and to improve the signal quality. All these things are true only because of the process of modulation, and that's why modulation plays the very vital role in the electronic communication system. Then we have studied the types of modulation. One is analog modulation, second one is a digital modulation. In analog modulation, we classified this into three types. One is amplitude modulation, second one is frequency modulation, and third one is angle modulation. We also covered the types of digital modulation, that is amplitude shift keying, frequency shift keying, phase shift keying, pulse code modulation, pulse amplitude modulation, pulse width modulation, pulse position modulation. All these are the different types of digital modulations which are used to carry the digital signal from transmitting antenna towards the receiving antenna. Dear students, that's all about which we studied in yesterday's lecture. Today, we are going to proceed with one of the type of analog modulation, and that is known as amplitude modulation. Friends, amplitude modulation is used as far as AM stations are being considered. Students, you are well aware with the fact that there are FM stations as well as there are AM stations. Especially AM stations can make use of amplitude modulation techniques for transmitting the signal, and FM makes use of FM modulation. Out of two, today we are going to study details regarding the amplitude modulation. In shortly, it is abbreviated as AM. Most of the radio stations are there which are working on this particular principle. To make aware you to make the signal audible and also visible. Audio video on television system, only audio signal as far as radio communication is being considered. From that point of view, we are going to study details regarding the amplitude modulation, beginning with its definition, its mathematical expression, analysis of the same, how the amplitude modulation that takes place, its frequency spectrum, modulation index, how modulation index is effective to conclude the percentage of modulation that took place. All these aspects we are going to study under the title known as amplitude modulation. Let me begin with its definition. As per definition of the modulation, please do remember the definition of modulation. As we already studied that modulation is a process by means of which some of the parameters of high frequency carrier wave is varied in accordance with that of signal to be transmitted or signal to be modulated. Accordingly, small change we are going to do that will result the definition of amplitude modulation. Amplitude modulation is the process in which peak amplitude of the high frequency sinusoidal carrier wave is varied. In the definition of modulation, what we studied? And that is, some of the parameters of high frequency carrier wave is varied. Some of the parameters, which parameter here it is changing? Peak amplitude of, this is the parameter which is changing as far as amplitude modulation is considered. So peak amplitude of high frequency sinusoidal carrier wave is varied in proportional to, in accordance with what? Instantaneous amplitude of the modulating signal. Instantaneous amplitude of the signal to be modulated. Instantaneous amplitude of the signal to be transmitted. Means at a particular instant, as amplitude of the signal varies, in accordance with that, peak amplitude of the high frequency sinusoidal carrier wave is changed. This process we can call it as it is the amplitude modulation. As amplitude of the signal to be communicated changes, accordingly peak amplitude of high frequency carrier wave is changed. This is known as the definition of amplitude modulation. Let me proceed to study its mathematical analysis. To undergo mathematical analysis, let me consider Em equal to capital Em sine of omega mt be the modulating signal. Means the signal to be modulated, the signal to be transmitted is this one. We are representing in the form of sinusoidal wave, sine wave. Small e, it is the representative of signal to be modulated. E for voltage, EMF. M for modulating signal. Modulating signal voltage is given as capital EM, where EM represents the maximum amplitude of modulating signal. Capital E, it is amplitude representing the amplitude in the form of voltage, M for modulating signal. Sine, sine represents it is in the sinusoidal form. Omega mt, it represents angular velocity of modulating signal. Thus we can say small em equal to capital Em into sine of omega mt be the modulating signal, and in accordance with that, on the similar way we can say EC, E for voltage, C for carrier. The carrier signal voltage is given as capital EC into sine of omega ct. This is also in the form of sine wave. It is a sinusoidal carrier wave. It is given in the definition. Capital EC is the maximum amplitude of the carrier wave in the form of voltage, which is also in the form of sine wave, that is sine of omega ct. Omega c is angular velocity of the carrier wave. Thus, equation 1 represents the signal to be modulated. Equation 2 represents the carrier wave. All these two equations are to be analyzed with its terminology as where omega m and omega c means this omega m and omega c are angular velocity of modulating and carrier signal respectively. Whereas capital EM and capital EC means this capital EM and capital EC are maximum amplitude of modulating and the carrier wave respectively. In general, in short, we can say equation 1 represents the signal to be modulated, equation 2 represents the carrier wave. Now, as per definition of amplitude modulation, the peak amplitude means this is the peak amplitude of the carrier wave is varied in accordance with that of instantaneous amplitude of modulating signal. So instantaneous amplitude means EM. This amplitude EC changes with instantaneous variation in the amplitude of the signal to be modulated. Means EC changes in accordance with that of instantaneous amplitude of the EM. That is the definition of modulation. According to that particular definition, we can say after modulation, peak amplitude of the carrier wave changes. Peak amplitude EC changes so that modulated wave is represented as. Means after modulation, new waveform it is generated. It is called as modulated wave. Friends, equation 1 and equation 2 are represented in this particular waveform. So this is the wave that represents EM, that is modulating signal. It is in the form of sine wave. Look at here, it is in the form of sine wave. This is the maximum amplitude, that is capital EM, which I am mentioning here. Okay, omega ct it depends upon its angular velocity. Omega is equal to 2 pi f. So maximum amplitude of the carrier wave varies accordance with the time. This is represented in the form of sine wave. This waveform is a representative aspect of equation number 1, that is small em equal to capital EM sine of omega mt. The second waveform it is represented. It is a high frequency sinusoidal carrier wave. This represents equation 2. Look at here. Your time is less, means frequency is more. Your time is more, frequency is less. This is EC, that is carrier wave amplitude. This is EM. So here amplitude changes. Look at here. At that particular instant, here amplitude of the carrier wave also changes. This is the carrier wave. Try to look at here. When these two are superimposed, by definition, we can get the modulated wave which is represented here. Look at here. This is the signal to be modulated which is represented. When this carrier wave, this signal is superimposed on the carrier wave, then what happens? As the amplitude of the modulating signal changes, amplitude of the carrier wave changes. Look at here. Here is the amplitude of carrier wave less, here it is more, here it is more. Why this is? This is because amplitude of the modulating signal also increases. After this, amplitude of the modulating signal decreases. Look at here. As amplitude of the modulating signal decreases here, amplitude of the carrier wave within that, it also decreases. Here amplitude of the modulating signal is a minimum. Therefore, amplitude of the carrier wave is also minimum. Again, amplitude of the modulating signal increases, so that amplitude of the carrier wave at that particular instant increases. Means if the amplitude of the modulating signal increases, amplitude of the carrier wave also increases. If the amplitude of the modulating signal decreases, then amplitude of the carrier wave also decreases. What this means? This means that instantaneous amplitude of the modulating signal as it is changes in accordance with that of amplitude of the high frequency carrier wave changes. This is what we can call it as the definition of amplitude modulation. So this is a maximum capital E mod, that is amplitude of the modulated wave. This is the amplitude of modulating signal. This is the amplitude of carrier wave, whereas this one is the amplitude of the modulated signal, capital E mod. That modulated wave equation is represented as, look at it. Thus, the amplitude of the modulated wave, capital E mod, is given as ECM plus EM sine of omega t. This is E mod, means it is the amplitude. This amplitude is represented as capital E mod. E means amplitude. Modulated voltage is given as ECM, that is modulated carrier wave signal, plus EM sine omega t, it is modulating signal. This modulating signal is superimposed on the amplitude of the carrier wave. Due to this superimposition, amplitude of the modulated wave, it is changed. With this particular change of amplitude of the modulated wave, the modulated equation we can write it as E mod. This is as like EM and EC. According to this, we can write it E mod equal to capital E mod sine of omega ct. What is capital E mod now? Capital E mod is ECM plus EM sine of omega t. Put the value of capital E mod in equation number 4. That is from equation number 3 and 4. We can write E mod modulated signal voltage equal to ECM plus EM sine of omega mt into sine of omega ct. Now, ECM is taken common from this particular equation. If you take ECM common, we can write it ECM sine of omega ct into bracket 1 plus EM upon ECM sine of omega mt. Which one can write it as ECM sine of omega ct into 1 plus MA into sine of omega mt. Let me call this as equation number 5. This is known as modulated wave equation. Here MA represents the modulation index, depth of modulation or modulation factor, which is defined as the ratio of EM upon ECM. In this equation, I replaced EM upon ECM by MA. This MA we can call it as it is a modulation index of amplitude modulated wave. It is also called as depth of modulation. It is also called as modulation factor, which is the ratio of EM upon ECM. Thus, equation 5 represents amplitude modulated wave equation. Equation 5 is amplitude modulated equation where MA is EM upon ECM, that is modulation index or modulation factor or depth of modulation. This factor decides how much amount of modulation that took place. That is decided by the modulation index as a factor. Dear students, If we expand equation number 5 so as to obtain the frequency spectrum of amplitude modulated wave. That means from the frequency spectrum of wave, frequency of carrier wave remains same, but its amplitude varies in accordance with that of modulating signal voltage EM. For the frequency spectrum wave means these waves. From these waves we can say, look at here, the frequency of carrier wave remains same. Time here and time here, these are same. But what changes? Only amplitude of the carrier wave changes. Here amplitude is less, here it is more, here more, again less. Amplitude changes as amplitude of modulating signal changes. But frequency remains constant. Frequency doesn't change. Frequency of amplitude modulated wave doesn't change. It remains constant. Only the amplitude of the modulated wave that changes. That's why we can say from the frequency spectrum of the waves, we can say that the frequency of the carrier wave remains same, but its amplitude varies in accordance with that of modulating voltage EM. This modulating index can also be expressed as MA is equal to EC max, which is maximum carrier voltage, minus EC upon 2 times EC. Or this can also be represented as EC minus EC minimum upon 2 times EC. What do you mean by EC and EC minimum? Look at here. This is EC, maximum EC. This is maximum EC. This is EC minimum. Are you going to follow? Or you can say, this is maximum EC maximum. This one is EC minimum in a modulator carrier wave. EC minimum here it is EC maximum. These two values are considered, and then we can say modulation index equal to EC max minus EC upon 2 times EC, or EC minus EC minimum upon 2 times EC, or same thing we can write it as EC maximum minus EC minimum upon EC maximum plus EC minimum. How to obtain EC maximum and EC minimum? You can obtain these values from this. This is EC maximum. Look at here. And whereas this one is EC minimum. You can measure by using CRO and all other things. So that modulation index equation is given as EC max minus EC minimum upon EC max plus EC minimum. Let me represent equation 6. Equation 6 represents the modulation index of AM wave. If you want to express this modulation index in percentage, multiply equation 6 by 100 so as to get the percentage of modulation index, that is percentage MA equal to EC max minus EC minimum upon EC max plus EC minimum into 100, that is in percentage. Dear students, this is how modulation index is effective. Modulation index will decide how much amount of modulation that took place. If we expand now equation number 5 means, where is equation number 5? If we expand this means if you multiply this equation internally and perform mathematical analysis so that as to get E modulation equal to ECM sin of omega ct plus MA into ECM upon 2 cos of omega c minus omega m into t minus MA into ECM upon 2 cos of omega c plus omega m into t. Let me call this as the equation. Equation 7. Equation 7 is obtained by expanding equation 5. This is also amplitude modulated equation that consists of 3 terms. First is this term. If you look at this, it is same as that of carrier wave. ECM sin of omega ct or EC sin of omega that we have already represented. Look at here. This is what EC equal to EC sin of omega ct. This is the carrier wave, and in modulated equation, that is in equation number 7, this is ECM sin of omega ct. First term represents the original carrier wave. This is the second term where you can get it MA into ECM upon 2. What is ECM? Maximum amplitude of the carrier. It is reduced by 2 ECM upon 2 into MA multiplied by modulation index. How we can calculate a modulation index? It is calculated by using this particular formula. So by knowing modulation index, we know amplitude of EC. Where is amplitude of EC? Amplitude of EC is here. This is the amplitude of carrier wave. Look at here. This is the amplitude of the carrier wave. So modulation index ECM upon 2 into cos of omega c minus omega mt. Here is a difference of annular frequency of carrier wave minus annular frequency of modulating signal. Minus same amplitude MA into ECM upon 2 cos of omega c plus omega mt. What it indicates? It indicates that there is a phase change that took place. As far as second term is there, second term is MA into ECM upon 2 cos of omega c mt. It has a peak amplitude MA into ECM upon 2. This has peak amplitude MA into ECM upon 2. That remember, because maybe some mathematical examples are going to be asked on these. So peak amplitude of second term is MA into ECM upon 2, and the frequency is the difference between frequency of carrier wave and the frequency of modulating signal. It has a frequency, that difference between frequency of carrier wave and frequency of modulating signal. What is third term? Third term is minus MA into ECM upon 2. It has a peak amplitude same, that is MA into ECM upon 2. Means second and third term have got same peak amplitude but opposite in direction, opposite in phase. They have phase difference. So that's why it is represented with the minus sign. Again frequency, it is a sum of frequency of the carrier wave and frequency of modulating signal. Here it is a sum, here it is a difference. Here it is a positive phase, here it is a negative phase. So amplitude modulated equation after expansion, we get three terms. One is the original carrier wave having amplitude ECM. Second term having the amplitude MA into ECM upon 2 with the frequency equal to frequency difference of the carrier wave frequency and modulating frequency. Third term having the amplitude MA into ECM upon 2 but in opposite phase, frequencies having the frequency, sum of the frequency of carrier wave plus frequency of the modulating signal. By considering this, we can draw the amplitude modulated frequency spectra. That is, this original carrier wave, look at here, at the center it is the original carrier spectrum. Look at here. This is the time, whereas this is the amplitude, EC or ECM we can say. So where is that? It is here, ECM sine of omega t. This is the amplitude. Look at here, this is the maximum amplitude, it is represented. What about second term? Second term is represented here. Here, this is represented with the amplitude MA into EC upon 2. Here it is there. Having the frequency Fc minus Fm. This is the frequency, or if it is time, then Tc minus Tm. Third term is represented as Fc plus Fm. Look at here, omega c plus omega. Omega is 2 pi c and omega m is 2 pi Fm. Fc plus Fm, it is represented here, and Fc minus Fm, it is represented here. Having the amplitude again MA into EC upon 2. Look at here. This is the amplitude MA into EC upon 2. What is the difference? This is on left side, whereas this is on right side. That is the phase reversal that takes place. That is the phase change that represents. So at the center there is a carrier wave representation in the form of voltage, in the form of amplitude as a AC. To the left side, Fc minus Fm. Second term representing amplitude of Ma into Ec upon 2. To the right side, Fc plus Fm, third term representation having the amplitude Ma into Ec upon 2. Friends, by knowing Ma into Ec and frequencies, you can draw this particular frequency spectra for amplitude modulated wave. This particular band to the right side from Fc to Fc plus Fm means up to this, it represents the upper sideband. Look at there, this concept plays the very vital role in forthcoming lectures. Please do remember. Means the right side, whatever bandwidth is there from Fc to Fc plus Fm, this represents the upper sideband. Whereas the band that represents from Fc to Fc minus Fm to the left side, it represents the lower sideband. This is LSB, that is lower sideband, whereas this one is the USB, that is upper sideband. Carrier wave is exactly at the center with maximum amplitude. What we are observing? The amplitude of upper sideband as well as lower sideband is half the modulation index into the amplitude of the carrier wave. For both, half the modulation index into amplitude of the carrier wave. Where carrier wave has got its maximum amplitude. Means from the point of view of voltage, we can say the carrier wave has a maximum power. Sideband has got less power. Because Ma upon 2 into Ec, that is the representative aspect of time. So as amplitude is less, power is less in the sideband. We are going to discuss details of all these things in forthcoming aspects. Please do remember to represent the spectrum of amplitude modulation. What we can say? It has upper sideband Fc plus Fm, lower sideband Fc minus Fm, both having the amplitude Ma into Ec upon 2 in opposite phase. Dear students, this is what mathematically we can analyze the amplitude modulation, and we can make you clear the concept of modulation index, frequency spectrum, and also the modulated waveforms. That includes modulating wave, carrier wave, and also the modulated signal. This is modulated signal. This is the carrier wave, whereas this one is the modulating signal. When modulating signal and carrier wave are superimposed, meaning thereby amplitude of the carrier wave is changed in accordance with that of instantaneous amplitude of the signal to be modulated. So that is called as the amplitude modulated wave. How much amount of modulation that took place, it is decided by means of a modulation index, which we have already studied here, that is EC maximum minus EC minimum upon EC maximum plus EC minimum into 100, that is given in percentage. Friends, don't forget once again the concept of upper sideband, concept of lower sideband. These are to be used in forthcoming lectures. Dear students, that's all about the today's lecture. Next time we'll go for some another aspect of continuation of the amplitude modulated wave, that is power distribution in amplitude modulation wave. Today we will stop.